We take a look at this first one. We've talked about different theorems throughout geometry, and we proved 3 of them at the beginning of this unit. We proved the linear pair-angle theorem, vertical angle theorem, and the angle sum theorem. Okay? We can now prove more theorems that we've talked about now that we have seen how to prove that triangles are congruent. So the first theorem we're going to look at is the isosceles triangle theorem. So if you recall, if 2 sides of a triangle are congruent, then the angles opposite those sides are also congruent. So if we look at this example, if AB and BC are congruent, then the angles across for them, so angle C and angle A, are also congruent. That's the isosceles triangle theorem. We talked about that at the beginning of the year, used it throughout. Okay? Well, we can prove this theorem. And when we prove this theorem, essentially all we are doing are triangle proofs. We're just proving triangles congruent. It's no different than what we've been doing this last week. Okay? So we look at this. This is prove the isosceles triangle theorem. But really, it's no different. We were given information, and we're going to use that information to prove that those 2 angles are congruent. Okay? It's a triangle proof. We are trying to prove that these 2 triangles are congruent, so then we can prove that their parts are congruent. It's no different than what we've been doing. Okay? So our first statement and reason every single time is our given. They filled that in for us. And our last statement is what we're trying to prove. They filled that in for us. Okay? So let's use those shortcuts. Whenever we are proving parts, so we're proving that angles are congruent, what's our reason every single time? CPCTC. Whenever you're proving parts, you should be writing CPCTC. Okay. When we're proving parts, what step do we always do before that? Prove the triangles are congruent. So look in your box. This is the only one that's talking about triangles, so I know this one has to go above it. Whenever you're proving parts, you have to prove the triangles. We don't know which one we're putting here, but it has to be one of these 4. Okay? Whenever you state that triangles are congruent, only one of these 4 can go in that reason. You never say that triangles are congruent and then put transitive properties. You never put that triangles are congruent and then say vertical angles. One of these 4 are the only reasons you can put in this box. Okay? HL we used to talk about, we don't even talk about it anymore, so you can scratch that out. So at the end of the day, if you have no clue what to put, pick one of those 4, you might be right. Okay? If you're looking at your phone, you're not helping yourself. You're putting yourself at a disservice because you're making this even harder than what it is by not paying attention. So let's take a look at what we were given. We are told that AB is congruent to CB. So I'm going to mark it. I'm told something's congruent. I'm going to mark it in my diagram. Took care of it. Okay. Then I'm told that BD is an angle bisector. So what do you think our reason for number 2 is going to be? Definition of an angle bisector. Okay. And I have a look in my box. That makes sense to me. There's an angle bisector choice in there. I'm going to scratch it out. Okay? So we took care of all of our given information. Okay? We were told we had congruent parts. We marked them. You're given vocab word, definition of a vocab word. So once you take care of your given information, look and see what type of triangles are these. Are they shared side or bow tie? They're shared side. What's our reason every single time we have shared side triangles? Reflexive property. Every single time. Shared side triangles, you always put reflexive property. That's the only time you put reflexive properties when you have shared side triangles. So if you have bow tie, you never put reflexive. And then again, we don't know what this is yet until we fill in the rest of our proof. Okay? So here, it's definition of an angle bisector. So are we going to put something about angles or about segments in our statement? Angles, right? Makes sense. Of angle bisector, I'm going to be saying something about angles. Well, we can rule this one out. That's talking about segments. We already used that one. That's talking about segments. Rule that one out. This one's talking about angles, but do angle bisectors make right angles? No, so that one doesn't make sense. Okay. So at least ruling some things out, you have a 50-50 shot of getting the right answer. But which one is stating the correct angles? Because BD is bisecting this angle right here, which means these two angles are congruent. Which one, the first set or the second set, are naming those two angles? First set or second set are naming those two angles? The second set. So that's what we're going to use. Okay. The reflexive property. Whenever you have shared side triangles, you put reflexive property, and your reason is the shared side is congruent to itself. Well, what's the shared side? What side are they sharing? BD. So you just say BD. Oh boy. Oh boy, it got really off. You just say BD is congruent to BD. Try this again. Oh no. Oh no. Why are you off the board? Why, oh why, oh why? These sides do not work right now. There we go. Now it's working. BD is congruent to BD. And I'm going to mark it. Okay. Now we have to figure out, well, which one of those four did we use? So think about what you marked in your diagram. Did we mark 3 sides in our diagram? No. Did we mark 2 sides congruent in our diagram? Yeah, right? We marked that this side and that side. We have 2 sides and each triangle congruent. Well, isn't side angle side the only one that has 2 S's? So does it make sense that that's the one we're going to use? Yeah. So it's congruent by side, angle, side. We have a side, then we have an angle, then we have a side, right angle side. That's one way of ruling it out too. If you're unsure, look at how many sides you marked. If you marked 3 sides in each triangle congruent, then it's going to be side, side, side. If you only marked 2 sides in each triangle congruent, then it has to be side, angle, side. If you only marked 1 side congruent, then it's one of these 2, and you just have to figure out what the pattern is in your triangle. So at least you're narrowing things down as your options. Questions over that? Yes?
The question says 2 column proof. Is it always C, C, C?
Whenever you're proving parts. So whenever it says prove that angles are congruent or prove that segments are congruent, you always use CP, CTC. If it's saying like, hey, prove that triangle ABD is congruent to triangle CBD. If it just said that, it didn't say this, we would have stopped right here. We wouldn't even put that in. We would have just gone from here to here and would have been done. But in order to show that parts are congruent, you have to prove that the triangles are congruent. And once you say, hey, these triangles are congruent, well, that means their corresponding pieces or parts are congruent. So that's why we put CPCTC, because we're proving parts, rather than just triangles. This is a theorem we didn't really talk about, and that's okay. We didn't talk about it for a reason. It's not the most important thing in the world. But, and you're not going to be asked this on your test, this particular proof. Okay? But it is one of those proofs that are on there, on the standards, but it doesn't really come up on the OST, I don't think, that much, if ever. like to ask this one. Really like to ask this proof on your OST. And what's great about theorem proofs is they're the same every time. Literally the same exact steps, same exact reasons, in the same exact order, except your letters are different, because they might label them differently, different triangles with different letters. Literally the same thing every time with this proof. Isosceles triangle theorem, same steps, every time. Okay? This one, they don't really ask about, but it is one that they would like you to know, so I'm just going to show you, so at least you get more practice with these triangle proofs, and just figuring out what makes the most sense to put where. That's really what proofs are. Okay? So there's this theorem, and it says any point on a perpendicular bisector of a segment is equidistant, so the same distance from the endpoints of the segment. So we look at this diagram. MP is a perpendicular bisector, and M is a point sitting on that perpendicular bisector. So that means the distance from A to M is the same exact distance from M to B. Okay? Because it's sitting on the perpendicular bisector, so it's the same exact distance from the endpoints. Okay? So these two segments right here are congruent. That's what that means. Okay? Again, we don't really have to worry about this theorem. You don't have to remember this theorem. I'm never going to ask you what this theorem is. Don't worry about it. We're just mentioning it so you have an idea of why we're proving this. Okay? So this example, we're going to prove this theorem. But again, it doesn't matter. You don't have to know what the theorem is. You just have to recognize that all you're doing is a triangle proof. That's it. It's no different than if the directions just said, hey, complete this 2-column proof. And you were given this information and you complete it. Just because it mentions something about a theorem, it's no different. Same exact kind of steps. You don't even have to know what that theorem is. You can still figure out what the proof is. Okay? So let's use those freebies and those shortcuts. They put my given information first. Okay? They put what I'm trying to prove last. And they filled in some other things for us. Okay? Use those freebies and those shortcuts. Whenever we're proving parts, segment, or angles, what's my reason every single time? CPCTC. Every time. Proving parts, CPCTC. Scratch it out. Whenever we're proving parts, which one has to go above it? What's my statement directly above it? Saying what? The triangles. Well, I notice there are two statements involving triangles. Sometimes they do that to throw you off, to make sure you are paying attention. Okay? Knowing what you're talking about. So we have to figure out which one's the right one. Okay? Well, just highlight the triangles and see which ones look the same. So I'm going to highlight this first set. ANP and BNP. So go back up here. Here's triangle ANP. It's this blue triangle. Here's triangle BNP. It's a green triangle. Do those two triangles look pretty much the same? Yeah, looking at it, like, yeah, those look the same. Let's test the other one. The other one's saying A and B. A and B. So that big orange triangle there is congruent to A and P. No. Yeah, do those look the same? No. So are they going to be congruent if they don't even look the same? No. So that one doesn't make sense to pick. This one does. So I'm going to put that as my number 6, stating that the triangles are congruent. And again, whenever you're stating triangles congruent, it's one of those 4. Every time. One of these 4. We just don't know yet because we have to mark our diagram. But if you have no clue, just pick one and you might be right. Okay. So let's fill in the rest. Okay? We were told that PN in this diagram, I'm going to erase it so you can see this better, is a perpendicular bisector. Okay? Well, I have a vocab word. My reason's going to be definition of that vocab word. They wrote that for us. Okay? And what what they came up with from that is that A and P and B and P are right angles. Because we're dealing with perpendicular lines. That's what perpendicular lines for. So I'm going to mark them in my diagram. And we talked about this before. Whenever we're told we have right angles, what do we know about every single right angle? They all equal 90, right? So that means all right angles are what? They're all the same, which means they're all congruent, right? Whenever you're told that angles are right angles in a proof, you automatically, your very next step is to say that those two angles, this board's driving me nuts today, not want to cooperate. You automatically want to say that those two angles are right angles, and then that's your reason. A and P is congruent to angle BPM, and your reason is all right angles are congruent every single time. Right there. Use that one, use that one. Okay? Well, another reason says definition of a perpendicular bisector again. Okay, well I know perpendicular bisectors make right angles. What else do we know about perpendicular bisectors? It's a bisector, so what's it doing? Cutting in half. And what are we cutting in half? Are we cutting an angle in half or segments in half? Segments. So it makes sense. Something about segments needs to go there. Which segments are the same if we're cutting this side in half? Yeah. So that's going to be your reason that goes with this second definition of a perpendicular bisector. AP is congruent to BP. And it's right there. Okay. Well, whenever I see reflexive property given to me as a reason, I know my statement has to be something that is congruent to itself. And what type of triangles are these? Both side or shared side? Shared side. What do we know about shared side triangles? It's reflexive property. What side are they sharing? MP. So that is the side that is congruent to itself. So I'm going to mark it. And then I'm going to say MP is congruent to MP. And there it is. Or AM is congruent to PM. It doesn't matter. Oh no. Sorry. That one. Okay? They threw that in there to throw you off. AB is not the shared side. That's in there to throw you off. Okay, so make sure you pay attention. Because they might throw ones in there to throw you off. Okay? Now that we marked our diagram, which reason are we going to use to say that these triangles are congruent? Side, angle, side. What did I use? Side, angle, side. And again, one way of thinking about it, did we mark all three sides in each triangle congruent? No, so it can't be side, side, side. Did we mark two sides in each triangle congruent? Yeah, so it has to be side, angle, side, because this only has one side and that only has one side. By just thinking about it that way, we know what our reason is. Okay? Questions over that one? One more. We'll finish the rest of tomorrow. Okay, so this is one theorem we talked about a little bit in here. What's going on? Oh, it extended. That's fine. Sorry, probably making, if anyone's watching this video after I post it, very dizzy. And this is talking about parallelograms. We talked about parallelograms a little bit with symmetry. Okay? And there's two important things we need to know about parallelograms. It is that opposite sides are the same. So whenever you have a parallelogram, automatically the opposite sides are the same. AB and BC are congruent. AB and BC are congruent. And they're opposite angles are congruent. So this angle and this, this angle are the same, and D is congruent to D. Right. And you are going to be told, I like to kind of ask this one on the OST. And again, it's just a triangle. That's all it is. You're just proving that two triangles are congruent, and then stating that their parts are congruent. So you just have to use those shortcuts to help you fill in that proof. Okay? We are going to prove that opposite sides of a parallelogram are congruent by completing this two-column proof. So just think, oh, I'm just completing a two-column proof, proving two triangles are congruent. That's all you're doing. Okay? So when we fill everything in, they filled in my given, they filled in our last reason. We are proving parts congruent. So what is our reason every single time? CPCTC. Every time you're proving parts. CPCTC. Whenever we prove parts, what's the step right above it? The triangles. We use CPCTC. I know the step above it's going to be triangles. That's the only one talking about triangles, so I know that's the right one. Okay. The reason for number 5, again, is going to be one of these 4. We just have to figure it out. Fill in the rest of our proof. Okay. Well, if I look here, they gave me the statement for number 2. It's saying that AD is parallel to CB, and it said that AB is parallel to CD. Again, arrows do not mean congruent, they mean parallel. Keep that in mind. Well, what do you notice we were given in our given info? Were we given a vocab word? Yeah, parallelogram, right? So what reason do you think we're going to put with number 2? Definition of a parallelogram. It's a little bit different than what we're used to. I spelled parallelogram like that, so I don't feel like writing it all out. But whenever we have a vocab word, our reason is the definition of that vocab word. So it's definition of a parallelogram. Because we know the opposite sides of parallelograms are parallel. That's what makes it a parallelogram. Parallelogram means their sides are parallel. Okay? Well, we talked about this here. Whenever we're given parallel lines, or we have parallel lines in our proof, what kind of angles do we have all the time? What's going to be our reason when we're given parallel lines or have parallel lines? Alternate interior angles. Well, here, it's talking about how angles are congruent. I'm given parallel lines. Well, my reason has to be alternate interior angles are congruent. Okay? Another way of thinking about this, we're talking about congruent angles. These are my only 2 reasons talking about congruent angles. So if you don't know what to put, you have a 50-50 shot. Well, if we look at our diagram and we mark it, okay, if we mark angle DAC and BCA, and we mark the next 2 set of angles, if you're unsure what type they are when looking at it, do those look more like corresponding or alternate interior? To me, they look like alternate interior because they're opposite and diagonal. So you just kind of have to use your noggin and think about these things sometimes if you're unsure. Okay? I took care of my given, took care of all that. What type of triangles are these? Shared side. What do we always have with shared side triangles? Reflexive property. That's going to be my other reason. And whenever we have the reflexive property, it's always the shared side is congruent to itself. Okay? Well, what is the shared side? AC. This one, I know it's flipped. Sometimes you flip it because the shared side is diagonal, so you flip the direction. But that has AC, that has AC, that's the same thing. Sometimes that happens. They flip it when you're sharing slides diagonal. Just know that that's the same thing. The letters are just flipped. Okay. So if we look at our diagram, did we mark 3 sides congruent? No. Theorems don't mean congruent, they mean parallel. So we did not mark 3 sides congruent, so it can't be side, side, side. Did we mark 2 sides congruent in each triangle? No, so it can't be side, angle, side. So now 50-50 shot of getting the right reason. But what pattern did we follow? Did we follow angle, side, angle, or angle, angle, side? Yeah, angle, side, angle. So that's going to be our reason for number 5. Okay? You might be thinking, well, why is it not angle, angle, side? Well, if we started here at this angle, with the angle, angle side, you'd have to skip all the way over here. You'd be skipping this side, you'd be skipping this angle, you'd be skipping that. You're skipping way too much to get to the other part. You can only skip one thing. So that's why it's angle, side, angle. Okay? Questions over that?